a lot of combining like terms. Now, one of the things that I might have mentioned with you guys in the past is try not to do math horizontal. Don't write things out horizontally, okay? What I want you to do is when you line these things up, line them all up vertically. Don't write the problem down exactly the way you see it, because you know when you're adding these things together, you're just going to be combining like terms. Just jump right to it. When you're writing down a problem on the book, just start with the first and just line them up. Yeah. Just line them up. Notice I took a blank spot for the x term because there wasn't one. I basically am using it as a placeholder. I know that you guys have all done this before, and it is relatively straightforward. Okay. When you combine like terms, the biggest mistake you're going to make is you just forget how to add because you go too fast. You get 4x cubed minus 8x squared minus x plus 1. Notice how it nicely puts it in a descending order from there. We always put stuff into a descending order. All right? Now, what you're going to screw up is subtraction. And the reason that you're going to screw up subtraction is because they write it as subtracting the whole thing. Which means you have to distribute the negative. Here's what I would do. When I go to write these things out, again, I'm going to write them out vertically. So I have 5x squared plus x minus 7. And I know I have to subtract 3x squared minus 6x minus 1. What I'm going to do here is just put that subtraction sign into all of these. And I'm just making 3 subtraction problems. You might have done it this way in algebra, where you line them up vertically and just kind of went term by term. Doing it this way, it takes a brief second longer, but it forces you not to make the dumb mistake. Okay. So now you went with 5 minus 3, 1 minus negative 6, and then negative 7 minus negative 1. And you're done. Okay. Like I said, it just forces you to slow it down. That's all. I think it's a nice little tool to use. It's a nice trick. It keeps everything organized. I know that you guys all have your own way of doing things. I get it. It's the way I normally, when I go to these problems, I usually just write them out vertically and just line them up. All right? Not so scary, I'm hoping. No. Oh, excuse me. Take a second and do those two.
Yeah, I like it.
So when I do this one out, I know it's subtraction. Now, what's weird is that I've got this extra term in the middle here.
Oh.
Because there's no placeholder there. So you probably did it in your head. So you have 6x to the 4th plus x squared plus x minus 8.
Yep, same change opposite. Yeah, boy. Let's go. Next type.
Yes, sir, Michael.
Sir Michael.
Adding and subtracting is hard.
I know, I lined up the x squared with the x.
Don't do that. Put placeholders in. If you made that mistake, Mike, just put a placeholder in. You know, put like a 0x or a 0x squared, things like that. It takes an extra second, but it'll force you not to make a dumb mistake. You get all excited and look there.
Yeah, man. I don't know what you were saying. Just heard my name. Yeah, man. I was just hoping it was. I'm sorry. I'm just trying to have a good day.
Weird.
All right.
Multiply. Oh no! When you multiply two variables together that have the same variable, different exponents, what do you do with the exponents?
Add them.
You add them. Basically, you wind up with a large distributive property here. You're distributing out and combining like terms. The only thing different that I do here that some people don't is obviously I get 3x cubed minus 2x squared minus 4x minus 9x squared plus 6x plus 12. What? Don't do it. Now, when I go to combine my like terms, what I normally do is I underline what I'm looking at, and I cross it off when I'm done. Now I'm going to combine the x squareds, -2 and -9. And I'm taking care of -4 plus 6. That's what I do that's a little bit differently than other people. I underline the pairs that I'm grouping together, and then I cross them off when I'm done. That way I don't accidentally add them in twice. That's all it is. It's just forcing me to add correctly. Okay? You don't need to do that. It's just a little trick that I did. What's wrong, Mark? I did both, yes. When? When you weren't looking. When I distribute, I'm distributing out the -3. That's where I got -9x squared plus 6x plus 12.
Oh, it's like two different things. Okay, I thought you were gonna like distribute that
Nope.
X first and then do it.
Yeah, I did. I am crazy.
Okay.
Speaking of.
Wait, I'm confused.
Doesn't take much. Man, I'm on fire!
Super hot fire. I spit that. This video. How does it have men? I watch that. Iced tea. I drink that.
Please help.
Super hot fire. I spit that.
What's up?
So when you do it, you distribute just the x first, and you go through and do all like the x times everything, and then
Yep.
you do the negative 3 times everything.
That's all it is. That's all it is. It's just distributed property. Okay. Here's 2 of them. Try it. Did anybody go the opposite direction here?
And do what?
Go 8x cubed plus 2x squared minus 10x?
Yeah.
Good. Does it matter what direction you go?
Not really.
Since we're multiplying, what property in math tells you that order doesn't matter?
How is it order population?
It did, yeah. Reflexive.
Oh, never mind.
Reflexive
I
property?
didn't say that.
Right, you didn't say that. Right, you didn't say that.
It's like you don't even know how to math. Our carrots are about to get ranch from the little shop.
Is that right? No, I'm not going to bother with it anymore. All right. Here's where things start to get interesting.
There we go.
Here's when things start to get a little bit more interesting. When things start to get a little bit more interesting, you've got just to do a little bit more work. Oh no, it is so tough.
Work.
Yeah.
You're stressed out.
And when you get stressed out, your head is going to explode. I love those commercials. So here's what happens. Yes, ma'am.
So would you would you take like the first 2 and like distribute those, and then you do those times the other one?
Absolutely.
Like
That's all you're doing. Now, to be honest with you, there's multiple ways of doing these. Right here, you've got 3 sets of terms. If you FOIL out 2 of them, then distribute the third. It works the same. It does not matter which ones you pick to start with, because you're still going to get the same answer, hopefully. When I see something like this, I'm going to find the 2 that are the easiest to multiply together right off the bat. They're really easy to go, so I'm not really concerned. But if I did the first 2, I can multiply those out real quick. X squared minus 3x plus 2. Distribute that to the x plus 3. X cubed minus 3x squared plus 2x plus 3x squared minus 9x plus 6. X squareds go away. X cubed minus 7x plus 6. And that's what we look at. Yes, sir?
What rule tells you have to FOIL instead of distribute?
FOIL is just another way of using distributed property.
I know what I mean.
FOIL is just a funny acronym for distributed property.
Make sure you don't put up in last.
Yep.
Guess what? We only did through 5 minutes, 5 more times.
The weird stuff comes into the special patterns. Now, what happens here with special patterns, oops, is the following. One of the things that you should recognize is you have the same terms, opposite signs. That means there's no middle part. It would drop out. Square the first, square the second, subtraction. This is a factored form of a difference of squares. That's the difference of squares. Okay. Remember, there is no such thing as x squared plus 9 to get you into 2 terms. It will not work, as we all know about imaginary numbers now.
Yeah.
The other thing about these special patterns is that it doesn't allow you, I don't want to use 2s, 2s are 2, let's use a 4. That's not x squared plus 16, is it?
No, it's x squared plus 8x.
Good. With some stuff in the middle. The shortcut for these, when you have junk squared problems, square the first, square the second, multiply the 2 together, and double it.
Oh.
Okay? Works the same if it's negative. If it's x minus 5, oops, quantity squared, I square the first, I square the last, multiply them together, and double it. Negative 5x doubled is?
Oh, that's pretty cool.
Wow, that was
You did learn that.
We did.
Yeah. But remember, a lot of times if you FOIL it out, you get the same thing as well. Yes, sir?
So you say you double it, you don't double the x.
When you double something, you aren't multiplying it by itself. You're just doubling the value. You're adding 2 of them together. Does that make sense? Now, the weird stuff is going to happen when you have, let's use x plus 3 cubed. This is junk times junk times junk.
Yes.
You'd have to multiply it out 3 times. Well, what we're doing here is we're expanding a binomial. There is something called the binomial expansion theorem, which we will talk about, I think, at the end of the chapter, maybe. But it's later on. What this allows me to do is, does everybody agree that I have 2 parts here, first and second?
Yeah.
The x and the 3? Here's what happens. To expand this out shorthand, cube the first, plus 3 times the first term squared times the last, plus 3 times the first term, last term squared, plus the last term cubed. What I want you to look at is what's happening with the degrees. Notice the degrees of the x term are decreasing. Starts at 3, 2, 1, 0. Because what's anything to the 0 power? 1. Notice how the other one is ascending. 3 to the 0, 3 to the 1, 3 squared, 3 cubed.
Okay.
It's a shorthand way of writing this out. It is. Because we're going to eventually be able to do stuff like this to the 13th power, and we'll be able to find out what the leading term coefficient is of the 7th term. It's very simple. Yes, ma'am? Yeah.
Oh, sorry. He said question, so sorry. So it's 3210 because it's cubed.
Right.
And so if it was like before it's 321. Okay.
The constants in the middle get a little bit muddy, but there's how this is formed is we'll figure that out later. Okay. We'll look at that later on. There's a reason why it's 3. I'm just not getting to it. Why? It'll always be a 3. It doesn't happen to be this. If this was x plus 5 cubed, this would still be a 3. So when you multiply all this out, then you wind up with x cubed plus 9x squared plus 27x plus 27. And that gets you a, I don't want to say, a distributed cubic. All right? Yes, sir?
Once the 3 number changes, the 3x.
For this stuff, no. That 3 doesn't change. This value 3 here does not change. I guess it was a bad example of me using a
But
3.
the parentheses stuff, that changes.
Yeah, yes, ma'am.
Can you explain how you got
Let me do it again. Yes, ma'am.
How does the square get on the 3 and the times 3x?
I'm going to redo it. Okay. Does everybody agree you have the first term that has to be cubed and the last term that has to be cubed?
Yes.
Okay. It's the junk in the middle that gets messy. We're starting with the third degree. So it's always going to be 3 times the first one, 1 degree less, times the last term, plus 3 times the first term, 1 degree less again, times the last term, 1 degree more, plus the last term cubed. So if you want, you could say that there's a 4 to the 0 here, and there's an x to the 0 there. Your first and your last terms are descending and ascending at the same time. That's how this works. It's a fast way of multiplying this out. Your final answer becomes x cubed plus 12x squared. 16 and 3 is what? 48. 48x. 64, thank you. Plus 64. Okay. And that's where this is going to. Yes, sir.
How do you get the 3?
It's given. It'll always be a 3. The rule is it's always going to be a 3. Okay, it's always. You all right?
I finally got it.
Why is ours good?
It's the rule.
If it's
It's just one of those things.
You'll see why it's like that when we do binomial expansion later.
It's kind of irritating.
It is irritating. Yes, sir.
so why do you square it?
Here, notice how it's going from 4 to the 0, which is 1. 4 to the first power, 4 squared, 4 cubed. It's ascending in degree, whereas the x is descending in degree. They're doing it at the same time. Now, the only thing that's different when there's a subtraction symbol is the signs.
Okay.
If there's a subtraction symbol in between the two, let's say it's x minus 5 quantity cubed, I'm still going to do the exact same thing. You all right there? I'm going to descend my degrees of x. I'm going to ascend my degrees of 5, but I have to be careful with the sign. So it's x cubed, 3x squared times 5, 3x times 5 squared, and then 5 cubed. Here's what you have to do with your signs. What's going to happen here is, if this first term, is that positive or negative? It's positive. That means the next one's going to be negative, which means the next one is positive, which means the next one is negative.
So it's like a little.
So then if there were like 6 terms, would it just keep going in that like pattern of positive, negative, negative?
Yes. Well, 6 is even. So, but there's a rule there that has to deal with, is it NCR? Number 2's permutation combinations.
Oh, I hated those.
You use the pattern permutation combinations of these things. We'll get to that, all right? But one of the things if you remember just this, a negative times a negative times a negative will always be what? Negative. So if you work backwards, negative plus, that'll help you. Okay? It's a very easy way to do it. And then the last thing you do is just multiply things out and simplify. It shouldn't be that bad. Because what this is going to eventually allow us to be able to do is that eventually we're going to have this problem.
Tell me this is not division.
It is.
I'm not good at division.
You're gonna be.
Wait, we have to do that problem?
We will. We'll do that on, what's that, Monday, I think?
Oh,
By Monday.
sweet.
I had to add science.
It's actually quite simple. No, we're using, this is regular boring long division. A little bit.
And I like
What you're using in division is that you have to use multiplication, addition, and subtraction all boiled in together. And this is very simple to do. Let me ask you this. How do you turn an x squared into 2x to the fourth? What would you have to multiply it by? 2x squared. So if I'm going to multiply it by 2x squared, which one of these do you think I'm going to put it over? The squared, because it's an x squared. So I put 2x squared here. Now, I multiply this times all of that. I get 2x to the fourth minus 4x cubed plus 4x squared.
Squared.
And then in long division, you would subtract them out, right?
Yeah.
So I'd subtract these. This goes away. I have 7x cubed minus 4x squared. I drop the next one, plus 5x. I ask the same thing. How do I turn the x squared into a 7x cubed?
Minus 1.
7x.
Nope, I'm not there yet.
Oh, okay.
7x cubed minus 14x squared plus 14x. I subtract them out. Gives me 10x squared minus 9x, and then bring down the 1. How do you turn an x squared into a 10x squared? Multiply by 10.
I mean, it's not that bad, it just looks really.
It looks awful, but you're using everything that we're doing today in this as well. 10x squared minus 20x plus 20. Subtract it all out. Was that 11x minus 19? And that's my remainder.
No, I think it'd be minus 21.
Negative 1 minus 20? It was minus plus positive 20?
I don't like this problem. I don't like any of this.
Sounds like a year job.
You're using all your addition, subtraction, multiplication rules that you're going over today when we get to this. That's all it is. It's extraordinarily straightforward. Yes, sir?
what you do, you get
You know, the 11x minus 9, and then y is the over the x.
It's your remainder. You know what? I want you to try this one.
I wrote down the captain's map.
Is there
There was
another?
no, there was no pictures.
We don't write A, B, like an X.
Yep. Try that one, guys. I want you to try that one with extra variables in there. So you can get that one.
I don't get it.
Thank you.
I have a type similar, except instead of like red, it's like equal to blue, and then dark blue black.
It's got a little gray on it. So one of the things that most people are going to screw up here is that it's AB is the whole thing, so the whole thing has to be cubed. So you wind up with A cubed, B cubed, plus 6A squared, B squared, plus, what is that, 12AB plus 8. What a lot of times people forget to do there, since AB is the whole thing, sometimes people just write it as AB cubed or AB squared. Don't forget to put the distributed components. Oh, don't forget to put 3's in there, that's important.
What are the A's for?
The rule,
There, please. I don't know why.
Threes are here for the rule, remember? Threes are here for the rule.
No, I know.
That's a lot of work.
That's nonsense.
That's a lot of work. Let's do some of this then. Let's see. Why is what?
It's like the rule. It's the rule.
The rule for this one is because of, oh, what check is that?
Well, with what? We just got a-
I think it's super.
Wow, it's not crazy. Why not? You only have to go through 4 minutes.
The reason that it's a 3 is the following.
You could have just accepted that there was a 3 there.
I didn't understand what the 3 was there for.
Well, no. Here's your explanation.
No, you don't. No, you don't. Okay, this is making less sense.
More questions lead to more lecture. That's why you still have to.
I like it. More questions lead to more lecture. All right.
Right there.
That should go on the window. I think that goes on the window. Oh, you might don't use screen. It doesn't show up. Just blue. Here's what happens. The reason that this is happening, the way that this goes, is you wind up with 3, choose 0, x to the third, 5 to the 0. Shh. In your calculator, you have a button that has probability. N choose R, P choose R, N, P, R, N, C, R. When you put this in your calculator, 3 choose 0, you get 1. 5 to the 0 is what? 1. So this is x cubed for this first chunk. The next part would have been 3 choose 2, oh, excuse me, 3 choose 1, x squared 5 to the first power, following the rule. 3 choose 1 gets us, I forget what it gives you, but it gives you the number. There's value as you go through all of these that it works. This pattern holds true all the time. It just continuously holds true. This gives you a 3. When you go to the next one being 3 choose 2, it also gives you a 3. All right? That's why these two middle terms are always going to be 3s. As you go on further and further and further, you can expand them out and get different numbers. That's why it works. You don't care.
So it would be 3 even if it was
I care a lot.
No, you
It would
don't.
be 3 even if it was.
Don't lie to me. Don't lie to me.
I care so much about everything having to do with algebra.
Are your eyes brown?
No,
Just checking.
they're yellow. They're really weird.
This is section, what is this, 6.3? Yeah, what was the, there's a whole dozen problems there for you, ladies and gentlemen. All right. Add, subtract, multiply, a lot of combining like terms. Put your chair flat, please. And going from there. Okay. Watch your combining like terms. Usually in your distributed property, that's where you guys can mess up with your negatives. Just be careful. All right. We're gonna graph polynomials tomorrow without calculators. and then go from there. Exciting. Yes, sir.
Like, no, it's only really takes, you know how extra